So this is the final sprint for the class. Here I'll be going over all of my subsystems and showing off what I've been working on. This is my everything in the kitchen sink file of this engine. So I've got a lot of random user code in here. Some of it has been kept track of, some of it not. So for existence, if you see something like this long string of nonsense here, that's because I haven't been keeping track of this file. However, I do have a model object that creates models without having to have that giant long manager line. So to better show that off, I have my demos that are fully kept up and look the way that they should, and I'll go through that code for the user's end a little more specifically so that I can show that off in the proper way. But to start off, we'll go over the update and draw. So the update and draw is pretty simple, just uses our command system. So use the command base for update registration and deregistration, and it so you just got this. Basically, you just got your updatable and drawable, which are both part of GameObject. You can register for update and draw, which will tell the scene to register you via the broker to its managers via update, draw, and update registration and draw registration, deregistration. So I can go through the update right here. So you just use update registration, ask the current scene to update you. Scene will just make a registration command and give it to the broker. The brokers just take in the manager and the updatable, and for their execute, they tell the manager to register. Here's my registration broker as well. It just has its add command, execute commands, and its delete. So then the updatable manager here just takes it in with the register, make sure that it's not already registered, and if it is, it asserts to warn the user they are double registering something. Otherwise, it'll add it to its list. Deregister just removes it from its list, and then it will process through on the update of the system to call the update for this is just the check duplicates, and then it's got its remove down here. Draw is the same thing, so I'm not going to go through that one just to save them time. So next, I'll go through the inputable. So for inputable, we have the inputable, the input marker, the single key manager, and the inputable manager. So just like before, you have your inputable, which is part of the game object. You can register and deregister for a key press or a key release, which will create a input marker. This marker is then sent through the scene manager, through the scene, just like the update was, exactly the same way. It finds its manager, which is the inputable manager. The inputable manager will then figure out which single key manager it belongs to via what key you are asking for, and if there isn't one, it'll create a new manager. So for example, if you asked for W, A, S, and D, it would create 4 managers, one for W, one for A, one for S, and one for D, so that those are all separated tasks. Then, just like before, we've got the command base over here, just has a input, registration, and deregistration. So this isn't the best example of this, like I said before, but just to quickly show, you can register and deregister, and here's your draw function and your update function, which are just overrides in here. Sorry, input is the key pressed, key released here, and then you've got your register and your deregister for all of those keys that you asked for, that you registered for. And then your key pressed is right here, which you just check for your keys, and key released right here just checks all those keys that you asked for releases on. So, show a little bit of that code. We've got our, a little higher, inputable, just like before, key event, registration, deregistration, not that big a deal. And then when you register, it checks if there is a single key manager with that key. If there's not, it'll create a new single key manager that it will check, that it will add your input marker to, and then I also make sure that it's not double making any single key managers. That would cause problems. Deregister just removes my my markers. I have an assert to make sure that I'm not trying to deregister any keys that have not been registered. The process just checks all the keys on all the managers. Check for duplicates, like I said before, and then just delete down here, which has a list of all of its managers so that I can delete all of the single key managers. So, single key manager, it's very similar to the other managers where it's checking for its key that it's been set up with, and it adds markers, checks to make sure there's no duplicate markers in itself, and can remove its markers, check for duplicates, and it's got its delete down here as well. So, next would be the alarmable. So, for the alarmable, we've got our alarmable, our alarm marker, and then its manager. So, just like before, you can register an alarmable. It will go through the scene manager. Well, first it will create an alarm marker. The alarm marker will then be sent to the scene manager via the registration to the scene, which will find its manager, the alarm manager, add it to the list of alarms in order based upon how soon it is before it will go off. So for commands, for this one that was a little different. We have our registration and our deregistration like before, but I also have an add time and a reduce time. So this allows the user to add time to an existing alarm or reduce time from an existing alarm so it'll go off sooner. These are also still using the scene registration broker. So we move down here to our user code. So we've got our alarms. There's 3 alarms. You register them. So this one's going to be going off in 4 seconds, 6 seconds, and 8 seconds. And then I deregister those alarms. And then down here, so when this alarm goes off, it's a repeating alarm. So when it goes off, it sets itself back up for another 4-second alarm, and it's drawing and it's setting up and it's registering and deregistering a sphere that it's created on screen to show that it's turning on and off. Additionally, I'm using the alarm get time for it, so I'm printing how much time is left in alarm 0 so that I can see how much time is before it'll go off, which allows me to make sure this is working. So at 6 seconds, right in the middle of this one going off for its second time, I will be adding 2 seconds on to this alarm. So it'll take 6 seconds to go off instead of 4, and it'll show in the bottom here. So it's going to be counting down. Once this hits 0, you can see it goes away, and once it hit 2, it went back up to 4, and now it's going back down to 0 again, and then it shows back up. So I've just added 2 seconds onto the alarm so that it will take longer to go off. I can do the same thing with reduce. So this allows me to reduce the time. So this will, at 4 seconds, it will go off once, and then the second time, at the 2-second mark, it will immediately jump down to 0, and we'll come back on and start back over at 4. So that's about it for the alarms user-wise. Showing off-wise, just got its alarm registration, deregistration, and then it's got its add time here, and reduce time, and get time, which are the different features that the alarms have. So this one returns a float. They all ask the scene manager to get some information for them. These are just asking for registration. This one is going to ask to get time. And then the alarm manager has its register and deregister here. Add time does the same thing as deregister, where it'll find the alarm marker that I've passed it, but instead of deleting it, it will set its trigger time forward by the amount of time that I passed it, and then I will re-register it so that it'll be in the correct spot in the list so that it doesn't block any other alarms from going off at the proper time. Same thing for deuce. I re-register it after removing the time to make sure that it doesn't block anything from going off at the right time. And then get time just finds that alarm and returns how much time before it will go off. Other than that, the rest is very similar. The alarm marker is just the alarm ID and an alarmable. So the next major system is collidable, so collision. So here we've got our collidable, and this is where we start getting a little more confusing. So we have our collidable has a sphere and a model, and it's using both the command test base and the command base. So the command base is for all of the registrations. So I'm using the collision registration command and deregistration command, just like all the other systems. So you can register, deregister a specific game object from collision testing. And then I also have the collision test self and the test pair. So these are connected to the test base, which allows them to be part of the collision manager's group of test commands. And then I can check all of the tests via the collision manager so that in the command test base execute, it's checking if there's been a collision. So in the collidable manager, there's the process collision tests, which calls execute test instead of just execute. And then on my registration collisions, we've got our test pair, which will test a pair of collisions between two different collider groups. And then there's the self pair test, which does work, and I will be demonstrating that as well once I'm done explaining this. So that's that. There's also the command group delete base, and this is because the collision group, collidable groups, which are whenever you register a collidable to the collision, it creates a group for that type of game object, so that, and that's templated, so we have to keep track of all those singleton templates. So whenever it creates a collision group, I create a collidable group command via the command base and the command group delete base, which the collision manager has a list of, so that when I delete the collision manager, it can go and tell all the collidable groups to delete themselves as well. So right down here, we've got our group delete commands, and I am telling all of the collidable groups to delete themselves, which should be right here, just to make sure I get rid of all that data. Other than that, I believe that's about it that we've got right now for the collision. It's the B-sphere collision. So math-wise, we've got our in our manager, or we've got our meshes, which is just the bounding sphere, which it sets the center, and it's got its radius. And then I can get that radius and stuff like that for when, let me just find this real quick, math tools. So you've got our math tools, which just has the intersect so that you can check if there's an intersection between the two spheres for if they're colliding or not. Other than that, I believe that's it for the collidables. Just froze a little bit there. So I can demonstrate that this is working. So if I go to the next scene here, whenever my ship starts colliding with, whenever the ship starts colliding with the houses, its sphere turns green, and then it goes back to red when it's not. As you can see, the two, let me just fly up here, the two houses right there are colliding with each other. That's why their spheres are green. And if I can shoot other ships, and if I shoot one of them, it deletes it, and it's no longer colliding with the other one, making it back to red, showing that the self collision works as it should. And then I can delete all these by shooting other guys. This is also for my life cycle, game object life cycle. So I've got these guys on a timer, and as you can see in the bottom, I'm creating recycled chips, and I can just make as many as I want. So continuing on, oh well, yes, next would actually be the life cycle. So I can show off. I was just showing off how I can shoot as many of those things as I want. They'll be recycled objects. So we've got our creating new ships, and from the recycled and registering and deregistering them properly. I can show that down here in my ships factory I got going on. So it simply just creates a ship and recycles the ship. Some functions that we've created. Create our ship, which just make sure there's not one in the list. If there's not one, to create a new ship. If there is, it'll use the recycled one. Call initialize on our ship here, so that it sets it up properly. Additionally, I've got the delete here, so I delete all those items, but to make sure that the user might want to keep those things through scenes, I created a permafrost resource called game end destruction. So here I would tell the user to delete any of their factories, because this will only be called once the game is closed, so that even between scenes they can continue to use those recycled chips. Next would be some of my assets here. So we've gone over alarmables, collision, inputable. So let's do these assets. There's the 4 managers. There's not too much to show about them. They all have their deletes, their get, load. I'll show off the texture manager because that one is a little different. So texture manager here is a singleton, allows you to load and get textures. This one allows you to load model textures. So you can load a texture by giving it the key and the path to the texture. From most of the time, you're just going to use its folder path, so it's not a big deal. The load model texture, you give it a model and that you've already loaded, and a key that you want those to be, and it will put those in as the texture, the name that you give it, plus the number in semicolons after it. And then you can get a texture, and then delete here. We'll delete all those textures. We've got the sprite as well, which is the other newer one. The other ones are very similar to that one, which this one just loads a texture from the texture manager and then creates your image so that there's a loaded sprite. And you can get your sprite. Same deal, delete it. All my deletes are in the permafrost engine. So I'm deleting my time manager, my sprite, scene, model, texture, shader, managers are all getting destroyed here. First, I'm calling that endgame destruction for anything the user wants to keep throughout the game until the end. So this is everything that happens right at the end of the game. The next thing would be time. So just close a couple of these, organize this a little better. Back in here, we've got our time manager. Just lets us get our time by using the freeze time, so that time stops actually when so that the alarms don't get messed up when you pause the game via F10 and step forward via F11. So the freeze time's in the tool here. So you just, I mean, you basically gave this to us, so I can't imagine looking for too much here. But you just, it's got its wait and remove with the hacked key release information there, so that the time manager has the right time. So as you can see here, I mean, the alarm's counting down there. If I hit F10, it's going to freeze the frame. I can step forward. It's going to call one update, and you can see the time slightly go down for that alarm because time is actually being stopped via the game. And I can continue it. It'll continue its countdown there. So that's about it for that. Some other just various systems that we've worked on, or that I've worked on. So we've got the asset managers we've gone over, everything for game objects. We've gone over the alarms, the collision, draw, inputable. So go over the game object itself. So whenever you create a game object, it'll call setup registration for you, so that you'll be registered into the system. And then it has a setup deregistration and setup registration, which are what are used to register and deregister it from the system. This is very useful when you're using a factory. So when you create, when you get rid of an object, you can call setup deregistration, and this won't actually delete it. It'll just deregister it from everything, so that you can then push it into the stack of recycled objects that you have. And then when you create one that's registered, you simply call registration, and it'll re-register it to everything that you've asked it to be registered to. On the user's end, I've made it as simple as I can by just having two functions called setup object and deregister object, that if you ever want to register anything, you throw it in here. And if you ever want to, and whatever you register for in here, you put in here as a deregistration. I have explained that in my demo so that the user knows that everything that's in here is registered. Anything that you register for in there, as well as anything else that any alarms that you register that are not in there, need to be deregistered or in here. So that is what the setup manager does. It just makes sure that make sure that the register and deregistration for the game object goes smoothly. Make sure you don't double register, stuff like that. Gone over update. So that pretty much does it for the game object. Registration brokers. I mean, we've gone over. I showed off the update one. All of them are pretty much the exact same thing. I can show off the test self pair if you want a little bit more, which has its execute, test execute. So it's a little bit different here because it has two executes, which is the one that registers it, and then the one that tests for the collision, which is why I had the two different command bases there. Otherwise, all this is very similar to each other. I have a different broker for the scene, so that if the user wants to change scenes, that'll be done first, and then nothing else will happen. So that if this broker it goes through and it needs to change scenes, it'll change scenes and clear the regular registration broker, so that the system doesn't even bother doing any of that. I can show that off in here. We've got our, I believe it's or was it? No, it is in here underneath the other ones. Or am I crazy? Sorry, yeah, no, I'm crazy. Sorry. Scene. I don't know. I was looking at that file. So for scene, in the update, we've got our registration broker execute commands. We process. Well, basically here we're just doing everything. So we're doing our alarms, our inputs, our update. But before this is called, so in the this should be right. It should be in here. Scene manager update. Oh, scene manager. Right. So the scene manager gets updated. Just that real quick. And it will first make sure that it doesn't need to execute any scene registration commands. Then it will process elements for itself, which is any scene registrations that should be coming up, and then it will ask the current scene to update. That way, this gets done first. Nothing else happens if a scene gets changed. If a scene wants to be changed, the user calls a function called set scene change register. Yes. They call the. It's so hard finding this stuff sometimes. So they call the register, which will go through the command pattern to change scenes so that you don't try to change in the middle of an update. So the user calls set new scene change. This goes through the command pattern to make sure that nothing gets messed up by trying to change scenes in the middle of the update because or the middle of the draw, because by doing this it crashes because it deletes a lot of stuff when you end the scene and it tries to do something that's not there anymore. It can't be done in the middle of an update. So you register for it through the command pattern so that it's done before everything else, and then nothing gets messed up there. So that's about it for that. Some other things that are just useful stuff that's in there. So we've got the freeze time, which I've shown. I created a God cam for the user, so they basically just add it to their scene as a game object. So we've got this God camera object. You just add it and delete it. I could show off how it works. You just hit F9 and it switches the camera to a God cam so that you can fly around and get whatever angle you want. And then you simply hit F9 again. It'll switch you back to your system's camera. F9 again, puts you right back into the God cam. So it's just a nice, useful tool that I have for the user to use. Some other tools that are in there are the math tools, the model object, and the sprite object, which the model object is just a template for creating graphic object so that you don't have to ask all the managers all the information. You just give it the names, and then the system asks all the managers to get that information for you. The same thing goes for the sprite object. It just uses all those sprite models and stuff like that that every sprite will be using. So the users type that in, and you just have to give it an image, or you can give it the image and a rectangle so that you can set up the ratios yourself if you want. So that also makes a good point that I have a load system resources, which is just a list of things that the system needs. So like the bounding sphere, the bounding box, sprite model, some of the shaders. These are just things that the visualizer uses and the system uses. So I have them in a separate file so that the user knows not to delete those. So we've got our assets, which are model shaders, and then textures and the system assets, which is where all that lays. And there's, of course, the visualizer, which I've already shown off works. I've got it on the house here, and then I've got it changing colors here on my flying ship, which is way more difficult than it should be to fly.